Good day, everyone. So the next question we are looking at is example 7. Remember that we have just learned about y equal mx plus c. So m represents the gradient and c represents the y-intercept. So for part A, we notice y equal to 2x plus 1. So answer is very simply m is equal to 2 and c is equal to 1. If you actually take reference of y equal to 2x plus 1 with your y equal to mx plus c. Now for part B, where we look at y equal to minus 5x plus 4, same scenario as part A, we do a comparison and we realize that actually for part B, our gradient m is actually equal to minus 5 and our y-intercept c is actually equal to 4. Now for part C, we notice that the equation of the line is y equal to 2. Now this is more interesting because actually you realize that this y equal to 2 is actually not of the form of y equal to mx plus c. Okay, so when we actually see the equation of the line as y equal to 2, okay, what we have to do is we can look back at the formula for our gradient. So for part C, now I understand that previously at the top, you all learned that the gradient of a line is y2 minus y1 over x2 minus x1. Now, what does this actually mean? This actually means that the gradient is change in y divided by change in x. Okay, so when we look at this, y equal to 2 is in fact similar to this line on the right hand side where we have a horizontal line. So suppose this A is actually 2. If this A is actually equal to 2, okay, I'll use another color. Then the equation of our line is as what the question required, y equal to 2. Okay, now take note, it is a horizontal line over here. So if it's a horizontal line, what is the change in the y value? Yes, you're right. Looking at this horizontal line, there is in fact no change in the y value because it's a horizontal line. So as a result, our change in y will actually be 0. Now, change in x itself, okay, it depends on the x values that we are looking at. So actually, if I have example here as 1 and here as 5. Okay, so basically this means that this point over here is 1, 2 and this is 5, 2. Okay, so when I look at this, my change in y, okay, this one I'm going to apply according to our formula. Y2 minus y1 over x2 minus x1. So this gives me 2 minus 2 because both y coordinates, both y values for these two coordinates are actually 2 divided by 5 minus 1. So this gives me 0 over 4, which is actually simply 0. Okay, now this question I'm doing it a bit longer because I need you to be very clear why is it that a horizontal line over here has gradient 0. Okay, so the y-intercept for part C, y-intercept is actually the value at which the graph cuts the y-axis. So this is very simply 2. Okay, so I hope this actually makes things a bit clearer for part C. Now, for part D, when I have this line x equal to 3, okay, I'm going to just draw it out on the right hand side so that you'll have a clearer picture. So I'm going to draw it with a green line over here, where this is 3. Okay, suppose I have 2 points over here, one over here and one over here. Let's say this is -2 and this is -4. Okay, so looking at my part D, if I want to find the gradient of part D, my m is equal to change in the y value divided by change in x values. So if I look at my y values, it will actually be my -2 minus -4 divided by change in x. Now, notice that the x value on both points is actually 3. Why? Because actually the points are 3, -2, and this is 3, -4. So I can have -2 minus -4, and at the bottom is actually 3 minus 3. So this actually gives me -2 minus -4, minus is actually plus. So -2 plus 4 is actually 2 divided by 0. Now, if I have a denominator as 0, what happens? Yes, it basically means that the gradient is undefined. Okay, so actually for this question, you can simply state that m is undefined. Okay, likewise to part C, I am actually writing it in greater detail so that you are clear why a vertical line has gradient as undefined. Okay, so now going to the y-intercept of the graph x equal to 3, we realize that this green straight vertical line over here does not intersect with the y-axis at all. So very simply, our y-intercept does not have an answer. So C is not applicable or no answer in itself. Okay. Now moving on to the example 8. Okay, for part A. Okay, M will be equal to 3 and C will be equal to -3. For part B, M will be equal to, this is -x minus 3, so it's -1, and my C, y-intercept, is actually equal to -3. Okay, now for part C itself, we have the horizontal line. Now, interestingly, y equal to 0, what kind of line it is? Yes, you're right. This is actually referring to the x-axis. Okay, so for part C itself, our gradient, as we learned previously, gradient of horizontal line is actually 0, and the y-intercept C is actually what value? It is the y value at which the graph intersects the y-axis. So in this case, this is the line y equal to 0, which is our x-axis. So it intersects the y-axis at 0 over here. So the y-intercept is actually simply 0. Now for part D, we have the graph x equal to 0, which is actually our y-axis. Okay, so the y-axis itself is also a vertical line. So from what we have understood in the previous example just now, for vertical line, our gradient will actually be undefined. Okay, now for our y-intercept C, okay, the line that we are looking at now is actually this vertical line over here. Why? Because it's the line x equal to 0, which is actually the y-axis. So actually there's an overlapping over here. So in that case, our y-intercept C will actually have infinite solutions, which is actually N8 for our y-intercept. Okay, so we hope this actually makes things clear for example 8. Okay, now look at example 9 now. Okay, it is a question where we need to actually learn how to use the formula of y2 minus y1 over x2 minus x1 to find the gradient of a line. Okay, so first things first, determine which point will be your point 1 and point 2. So in this case, I will have A as my point 1. So since this is point 1, it means that this will be your x1, y1. And for part B, this will be our point 2. So this means that this will actually be my x2, y2. Okay, so my gradient for part A, M, will be equal to y2 minus y1 over x2 minus x1. So this gives me 4 minus 0, y2 minus y1, 4 minus 0 over 2 minus 1. So this gives me 4 over 1, which is actually simply 4. Okay, for part B, likewise, my M will be equal to y2 minus y1 over x2 minus x1. So my y2 will be 2 over here, 2 minus of 2 divided by minus 2 minus minus 1. Take note of the negative signs, it can get a bit confusing at times. So this gives me 0 over minus 2 minus minus 1 means it's minus 2 plus 1. Minus 2 plus 1 is actually my minus 1. So 0 divided by minus 1 is simply 0. Okay, now on to the next example, example 10. Likewise, gradient M will be equal to y2 minus y1 over x2 minus x1. So in this case, I'm going to jump in. This gives me 9 minus 6 over minus 3 minus 10. Okay, let me write this a bit more clearly. So in this case, what I have is 3 over minus 13. So answer is very simply minus 3 over 13. Okay, so on to the next example, part B. So this is part A. Yeah? Okay, in part B, we have M equal to 2 minus minus 4 divided by 4 minus minus 4. So this gives us actually 2 minus minus 4 is actually 2 plus 4, which is 6. And 4 minus minus 4 is 4 plus 4, which is 8. So this actually gives us 3 over 4. Okay, I hope this has been clear to you. So that's it for today. Thank you.